real numbers and the coordinate system. And sorry for the shadows. Hopefully you can see this. If you can't see it, just let me know. Maybe I'll change colors and it'll work out a little better. Okay. So what are real numbers? Our whole entire system is made up of real numbers. Whatever number you can think of is real, like the square root of 25, negative 0.47, 0, a third. Those are all real numbers. What would be not real numbers? Excuse me. Now I have to let my dog out because he heard someone come in. I did trap him because. Did you take care of him?
Yes, I got it.
Thank you.
Is it good enough though? Oh, yeah.
So, sorry about that. Not real numbers we're going to get into are those imaginary numbers where we're taking the square root of a negative number. But everything else that you can think of is considered a real number. Now, real numbers are separated into two groups. Those two groups are rational and irrational. And here's how I tell my students to remember it. Rational is a ratio or can be made into a ratio or can be made into a fraction. If you can make it into a fraction, it's a rational number. For example, square root of 25 is really 5. And 5 can be made into a fraction, 5 over 1. 0 is 0 over 1. 1/3, that's a fraction. This is a fraction, okay? Even decimals that repeat, like point, 6666666, that's really 2/3. Negative 0.5, square root 16. So anything that can be made into a fraction, into a ratio, is a rational number. Irrational numbers are those famous, the most famous one that you can think of is pi. Okay, pi is your famous irrational number. It goes on forever as a decimal and it never repeats. 3.1415926, I don't know the rest, but that's as far as I can go. And it goes on and on and on. Square root of 2, if you type that into your calculator, it goes on and on and on. It never stops, it never ends, it never repeats. It's irrational. Okay, so irrationals are decimals that never end and never repeat. Okay, so those are our two main groups. This is really important that you're kind of following this because you will be asked questions on the homework about these. Now, under rational, we subdivide our numbers. We take out all the decimals, we take out all the whole numbers, we take out all the negatives. So we have all these subdivisions. So the first subdivision we make is integers. And we love integers, okay? Integers are all the numbers that are positive and negative, but they can't be decimals. They are not decimals. No fractions. Let me write that down. No fractions. No decimals. Don't get tricked. Don't be like, oh, and a negative 1/2. Oh, that must be an integer. No, it's not an integer. Integers are -2, -1, 0, 1, 2, 3, on and on and on, both ways. Okay, all the positive and negative and 0 whole numbers. Those are integers. Under integers, we have whole numbers. And the way that I remember whole numbers is it starts at the whole. That's where it starts. Starts at 0. So whole numbers would be start at 0 and then go up 1, 2, 3, on and on and on. Again, there's no fractions, there's no decimals. From here on out, from integers on down, there's no fractions or decimals. The only fractions or decimals can be up in rational or irrational if it goes on, if it never ends and never repeats. And then last but not least are natural numbers. I think this book might call it counting numbers. I have to remember. But think of a 5-year-old when you say, hey, start counting how many pencils there are. They're going to start with what number? The number 1. They're not going to be like -12. You know, they're going to be like, no, 1, 2, 3, on and on and on. They're not going to give you 5.9 pencils are on the ground. Okay, so those are natural numbers. Now, let me explain something to you. If you belong to natural, you belong to everything above it up to real. If you belong to whole, you belong to everything above it up to real. So that's the trick. That's why we write this down. That's why we take notes. If you belong to integers, you belong to everything above it up to real. Okay? The only thing is you cannot be a whole and be irrational. You are not a part of these are two separate groups. Okay? So if you belong to anything in this category, you belong to everything above it. And that's what they're going to ask you as an example on the homework. So just to give you an example, they're going to give you a list of numbers, which I'm going to write down right here. -8, 0.56, square root 4, square root 3, and -1/2. And they want you to list all of the natural, list all of the whole, list all of the integers, the rational, the irrational, and the real. And you'll have to type it into MyMathLab. So we'll start with this one real quick. So again, I would probably start right here at the bottom with the reals. All of these are real. There's no i's. I haven't thrown that at you yet. So -8, 0.56, square root 4, square root 3, and -1/2. They're all real. Okay. Now, which one is irrational? Which one is that weird one like pi that if I take the square root of it, usually it's a square root, you know, or it's a decimal that goes on forever and ever and never stops and never repeats. It's that square root 3. Okay. So then that means all the rest, the others must be, this is the irrational. So all the others must be rational. So you just write them out. -8, 0.56, square root 4, and -1/2. And then from there, you can decide which one is your integers, your whole, or your natural. So integers, again, can't be anything beyond rational. These right here can't be decimals at all or fractions. They cannot be decimals or fractions at all. So integer can't be a decimal, can't be a fraction, so could be -8. What about square root of 4? Square root of 4 is 2. So square root of 4 is also an integer. And then here for whole, can't be fractions, can't be decimals. It's going to be one of these, but it can't be negative. Whole starts at the whole. Starts at 0 and goes up. So square root of 4, because that's 2. And then natural is a counting number, like how can you count? Well, square root of 4, since it is 2, is also a natural number. So that will be a question, just like on your homework. Please use your homework, use your notes, because that's why we do them. All right, now let's quickly talk, let me move it like this, about the coordinate plane, which I'm sure you're familiar with. This is part 2. The coordinate plane. And just really brief, you've got your x-axis, which is horizontal. You've got your y-axis, which is your vertical line. They meet right here at what's called the origin. And that is the position 0, 0. 0 on the x, 0 on the y. You are dividing your coordinate plane into 4 quadrants. And to refresh you on how the quadrants are named, they're usually named with Roman numerals, and they always start in the upper right corner. This is quadrant 1. This is quadrant 2. Then go down. So you're going counterclockwise, starting at the top right. Quadrant 3, and then this last one is quadrant 4. If you land, let's say you draw a coordinate right there, you do not say that you are in a quadrant. You would just say that you're on the x-axis. Okay? And the reason why I want to set you up with that is because I want you to understand the graphing calculator viewing window. And you'll be asked some questions on MyMathLab homework about this. Graphing calculator viewing window. So they're going to give you a window. Let's see here. Let me draw it out. And they'll give you a number up here. And let me see what this is. We got that one. Okay. And they're going to ask you the following questions. I need to know what your X min is, what your X max is, your X scale, your Y min, your Y max, and your Y scale. And the reason why we do this is because when you go to your calculator, your graphing calculator, and turn it on, if you hit up here where it says window, that's what is located right here in your graphing calculator. Don't worry about the XRes yet, or this delta X. Let the calculator work on that all by itself. But you can adjust this window to help you find an intersection of points and whatnot. So looking at what I've given you here, let's determine what our viewing window is. So it looks like, again, this is my x-axis. It looks like my x min would be -10. My maximum x in this viewing window is 10. And the scale at which I'm going up looks like I'm going by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my scale would be 1. Looking at the y-axis, my y min would be down here, -1000. My y max is 500. But this time I'm not going up by ones, I'm going up actually by 100, 100, 200, 300, 400, 500. Same thing down here. Okay, so they're going to ask you a question like that. And they may ask you to write this in an interval notation, just so you know, meaning your X interval would be like this, from -10 to 10. Whereas the Y interval, and you always do low number first, high number second. So y interval would be negative 1,000 to 500. So we have an easy question about that. Like I said, they'll give you this window. You're just looking for the minimum number on the viewing window, the maximum number, etc., and then what you're going up by. So I think pretty easy stuff. Okay, it's all basic. All right, then the next thing you'll have to do is find some roots on the calculator and round it to the thousandth. Thousandth. Okay, and if you don't remember what the thousandth place is, that is your third decimal. You have to be really careful on MyMathLab because if you round incorrectly, it's wrong. So I'd hate to see you do that. So we're just going to do a few examples. I'll show you how to type it into your calculator and round. Let me write out a few of these real quick. The fourth root of 12. C is 3.8 minus 1.4. 3 pi to the fourth. And I'll do one more. And again, if you're missing any of these notes, you can easily, since I'm recording it, go back and watch it again. But let me just show you on the calculator. Brilliance on the calculator. There's the light. There we go. So your square root button, you know, is above the squared, so you'd have to hit second square root. There you go. Ooh, there's a glare. And hit 23, and then make sure you round it to the third decimal. So that 8 would tell that 5 to go up to 4.796. The fourth root of 12, you could hit math. And if you hit math, there is, you can actually see right here, there's a cube root, and then it says X root. Now, mine is a newer calculator. Mine's the TI-84 plus C. So it'll actually give me a box right here, and I can actually hit 4 and then put a 12 here. If you have an older calculator, like an 83, you actually would have to type the 4 first, then hit math, then hit that button number 5. But that's what you would have to do for that one. Another trick, which I'll show you in a minute. But let's see, 1.861. If you didn't know this, I believe we'll talk about it in this class. This is 12 to the 1. And then this becomes on the bottom. So you can actually do 12 to the power of 1 over 4, 1/4. 12 to the 1/4, 1.8612. 12 to the 1/4 is the same as the fourth root of 12. This one, be really careful when you're dealing with fractions. I always suggest to my student, use parentheses, put a parenthesis on top, put a parenthesis on the bottom. So I would actually go parenthesis 3.8 minus 1.4, close the parenthesis, then divide, then open a parenthesis again. The 5.4 plus 3.5, and then close it. And that will be accurate. I believe, if you don't know this, let me remember real quick. Nope. You hit alpha window. Yes, alpha and window. And you move over to where it says frac. And you see where it says N over D. My students love to use this all the time. I just don't as much. But it'll make a fraction right there for you. Then you wouldn't have to add the parentheses. And you can just go 3.8 minus 1.4. And then on the bottom, move the cursor 5.4 plus 3.5. You get the same answer. And so this would be, let's see, that 6 would actually round the 9 up to a 10, which means this becomes 0.270. When dealing with pi, you want to use pi on the calculator. The pi button is located in the caret right above it, so you'd actually have to hit the second function. So let's see, what did I have here? 3 pi to the 4th, 3, and then you go second caret, so pi to the power of 4, and then move it over, minus 9 squared. And you get 211.227, and then that 7 stays the same. And then again, this last one, it's just understanding the grouping symbols correctly. So you would hit your square root first, and then put a parenthesis, 4 minus 1, oops. Close the parenthesis and raise it to a power of 2. Move it over and then put plus parenthesis negative 3. By the way, you want to hit a negative 3 here and a minus here, or else it'll say error syntax. Negative 3 minus 2 squared. You want to be very careful about the negative and the minus on a TI-84. So 5.831. So easy stuff for this first part. All right, almost done. Just want to go over 3 more things with you. Formulas, really, that you've probably heard and seen since high school. And the first one is good old Pythagorean theorem. We love it. Pythagorean theorem. So Pythagorean theorem is based off of a right triangle and right triangles only. You cannot do this for any triangle, only right triangles, okay? And just to make sure we label this correctly, opposite the right angle is known as side C, which is your hypotenuse. The 2 legs that make up the right angle, we can call either of them A and call the other one B. It doesn't matter, but these are your legs, the 2 ones that make up the right angle. And then Pythagorean theorem obviously is A squared. If you square this one leg plus B squared, you will equal the hypotenuse squared. And that is Pythagorean theorem. And you'll be asked to find the missing side of a right triangle. So let's see. Give you a right triangle here. B, 12, and 13. This is a very famous one. If you know it, good for you. But it's a famous Pythagorean triple. Just to show you what I do is I always go around and I label. So if this is B, the side that makes up the right angle is your A, and the side opposite is C. So I would do 12 squared plus B squared equals 13 squared. So 144 plus B squared equals 169. B squared is 25. And then take a square root and you get 5. If I remember correctly, if they want an exact answer, let's say you got like 62, square root of 62, just leave square root of 62, or they might ask you to round it to the nearest thousandth or hundredth, then you need to correctly round or else it's wrong. The other formula that you need to know is the distance formula. It's really good to memorize these, especially if you're going into calculus. Everybody, you definitely want to have all these memorized. So the distance for given 2 points, I was going to write all these out, but let's say we have a point P, and it's located at x1, y1, and Q is located at x2, y2. then the distance PQ, which we'll call D, is equal to the square root of, and it's very similar. If you remember, like, let's say slope formula, I know we haven't gone through that yet, but this should be kind of familiar. You subtract your x's and square it, and then subtract your y's and square it. And it really doesn't matter how you subtract your x's and how you subtract your y's. I mean, I just try to stay consistent. But that right there is your distance formula, and then you take the square root of it. So we're going to do a quick example about that one. Find the length of PQ, and they'll tell you that P is located at -8,4, and Q is at 3, -2. Now, I'm a firm believer in just labeling things. I mean, so many times I have so many students make such silly mistakes. And if you just take the time, like right now, like let's call this X1, Y1, X2, Y2. Your eyes play trick on you. So just label it. And now plug it into the formula. Put it in correctly. So the distance would be the square root of X1, which I labeled -8, minus X2, which is this one, 3. Square it, plus Y1, which is 4, minus Y2, which is -2, and you know that minus and negative is plus, and then square it. And you would literally just do what we just did on previous examples and put this into your calculator. But this will be -11 squared, so that's 121. And this will be 6 squared, which is 36. So that's the square root of 157. And this is called an exact answer. And I believe they're going to ask you that on homework. What's the exact answer? So you might not necessarily want to put the square root there when you type this in the calculator. Just put that in there. And then make sure your final answer has a square root in it. By the way, distance should never be negative. You should never get a negative here. If you're squaring numbers, you're not going to get a negative, okay? So if you got a negative, you did something wrong. Distance is always, always, always positive. All right, and sadly enough, the last thing to talk about, last formula, is the midpoint formula. What am I on? 7? Okay, so the midpoint formula is found between, again, you have a point x1, y1, and an x2, y2 coordinate. So your midpoint is you take your x's, you add them together and divide by 2. That's the middle x coordinate. Then you take your y's, you add those together and divide by 2. So think of it like this. If I have this line on the coordinate grid and I have x1 and y1 here, and I have x2 and y2 over here, and I want to find this middle point, I would just add these x's and divide it by 2 and get to the middle. And then I would add the y's and divide it by 2 and get to that middle. Okay, and it's very easy. It's a midpoint, it's a middle. So we'll do 2 last quick examples of this. So find the midpoint of a segment with endpoints (8, -4) and (-9, 6). And again, you can easily label x1, y1, x2, y2, and plug it into formulas. This is why I love math. It's a formula. Just plug it in. It works itself out. So x1 is 8 plus x2 is -9. And you're going to divide that by 2. So you add your x's divided by 2. Then we add our y's, -4 plus 6 and divide by 2. And it's a coordinate. It's one whole number for the x and one whole number for the y. So 8 plus -9 is -1. So I have -1/2 is this x value. And then -4 plus 6 is 2, divided by 2 is 1. So that is my midpoint right there. So really, really simple. Real quick though, let's work that backwards. What if I gave you a midpoint, given midpoint -5, 7, and then an endpoint at 8, -12. And I wanted you to find the other endpoint, which will be on homework. Okay, still pretty easy. Still not hard. Just going to have to do a little bit of an equation, which is still not that bad to do. So again, to give you an idea, here's what I'm doing. I gave you the middle right here. It's -5 and 7. And then let's say I gave you this endpoint right here is 8 and -12. And I want you to find this guy. I want you to find this x and this y. Okay, well again, it's not that hard. What you do is you add the endpoints, divide by 2, it equals that guy. Add the endpoints, divide by 2, it equals that guy. So if I add my x and my 8, divide by 2, I should equal that middle x, -5. For the y's, if I add the endpoints divided by 2, I should equal that guy. So y plus a -12, if I divide that by 2, I should equal the middle 7. And these are some simple equations. How do you solve, how do you undo a division of 2? You multiply by 2. So x plus 8 equals -10. X would be -18. And then multiply by 2, you get 14. And then add 12 over, you get 26. So that endpoint was at -18, 26. That's where that one was at. Now, that, my friends, is the lesson. So, hold on, let me see if I can stop.